Hello everyone. Sorry I won't be able to come in for Monday's lesson because I'm sick. So I thought I just pre-record this lesson so that you guys don't miss out. Make sure you watch it over and over again if you don't understand, and make sure you do the textbook question because next time we have a lesson, we'll move on to new content. Okay? So I have also uploaded the work solution for my for the textbook 8B and 8D. 8B and 8C. Make sure you check on Canvas under modules, okay? Under counting and permutation, counting and statistic. So that is to help you to solve out some question if you ever stuck. Okay, so today we're gonna do combination 8C. So I'll just write down here. So first, let's revise a bit of permutation. Okay, so permutation, for example, if I want to sit 6 people in 3 chairs, and then sequence matter, I want to find the permutation of, so find permutation. Find permutation of if I want to sit 6 people in 3 chairs. Okay, these 6 people are A, B, C, D, E, F. Okay, so if I want to sit them in 3 chairs, we've already learned how to do that. As we've got 6 people, A, B, C, D, E, F, and I want to sit these 6 people in 3 chairs and want to find the permutation. So last lesson we've learned it is if we have 3 chairs, okay, so that's going to be 6 times 5 times 4, that's 120. Now, I will introduce how do we represent permutation now, okay? As you can imagine, the letters, the word starts with a P, so permutation, it is P. If I want to find the permutation of I sit 6 people in 3 chairs, I just do 6 people in 3 chairs. That's the total number. So for example, if I have 10 people on the seat in 3 chairs, that become P103, okay? So the way to do it is 6 times 5 times 4. Also, I can also write it as 6 factorial over 3 factorial because it's 6 times 5 times 4. Make sense? And that can also be written as 6 times take 3 factorial, okay? Because I'll show you another example. If I want to permutate, I want to calculate the permutation of 6 out of, let's say 4. Okay, that's going to be 6 times 5 times 4 times 3. That's going to be 6 factorial over 2 factorial. That's going to be 6 factorial over 6 take 4 factorial. Okay, so as you can see, I could have a general formula which you can take home with. P and K equals to n factorial, and here will be n take K factorial because, for example, here n take K is 2. Okay, here n take K, 6 take 3 is 3. So this is your take-home message, okay? You could use anytime in a permutation scenario. For example, if I have, say if I want to calculate the permutation of 10, and I want to calculate the permutation 10 4, that's going to be 10 factorial, 10 take 4 factorial. Oh, good? Okay, so this is our permutation. A little bit of revision and a little bit of introducing of new content. Well, it's literally not really new. We've already been using this formula. We just don't really learned the writing of it, but we've known that we've been doing calculations. So now, thinking about the scenario, if I want to sit 6 people, A, B, C, D, E, F, in 3 chairs, but I want to find the combination of it. In other words, permutation is order matters. Okay, combination, take-home message, order does not matter. Okay, so for example, in a permutation, I could pick 3 from 6. I could just do A, B, C, A, C, B. I could do B, A, C, B, C, A. I could do C, A, B, C, B, A. Okay, I could also pick, say that's 1, 6, so there's 120, that's 6 of them. Okay, I could also do C, B, C, D, B, D, C, D, B, C, D, C, B. I could do, what's the other, C, B, D, C, D, B. Okay, it could go on and on until I finish 120, right? But in combination, all these will become 1. All these will also become another one, which is the second way. Okay, so you can see with combination, the permutation absolutely overcounted. Okay, so what do I do if I want to calculate the combination then? I want to select 3 people, couldn't care less about their order, just 3 people out of 6. Okay, with combination, I use C to represent. Okay, C and K, which means I select K people from N. You can imagine like that. I select K people from M people. Okay, in this case, that is, I select 3 people from 6 people. Okay, so I could always start with the, the total weights, 120, okay? 120, right? Okay, what do I divide for to get my combination? As you can see, all the 6 has become 1. The 6 has become 1. Another third 6 will become another 1. Okay, so it looks like I'm dividing a 6. Oh, good. But where does the 6 come from? It is actually, if you pay attention, the 6 is 3 factorial. What does 3 factorial mean? It is I pick these 3, the total weight is 120. I have to divide that 3 permutation, which means the, how to say that, the order of the 3 people. Does that make sense? Okay, so I have to divide the 3 permutation because each way I'm choosing in the permutation, the 3 will have to permutate. We'll have to do permutation to give you 6 options. So I can also write as 6 factorial over 6 take 3 factorial. That's from the formula. Okay, that's from the formula here. Okay, that's from the formula here. And then divide by 3 factorial. Okay, so that's divide by 3 factorial is, equivalent of times the 6 take 3 factorial and then 3 factorial, because you divide 3 factorial, that's times the, times the reciprocal 1 on 3 factorial. So therefore 3 factorial become the denominator. Okay, so from this one, we could actually easily just get the formula for permutation, which is if I want to pick from N, I want to pick K people from M people, that's going to be, first I have my permutation formula, and then you're going to have to divide the permutation of that K people. Does that make sense? Okay, so that's the take-home message. Okay, so for example, if I want to pick, say, C, let's just like make up a question. Okay, C, oh gosh, C 10 2, that's gonna be 10 factorial, 2 factorial, which is K factorial, and then 10 take 2 factorial. 10 take 2 factorial, 2. Okay, so 10 take 2 factorial. So that's also equal to 10 factorial, 2 factorial, 8 factorial. Okay? Okay, let's have a look at this example. How many different teams of 3 can be selected from a squad of 8? Okay, so it is very obvious and in real life, very common that we do not care about the order. All we cared about is a team of 3. So order doesn't matter. There's no restrictions. So with A, that's pretty straightforward. That's going to be C. I choose 3 out of 8. I would highly recommend you to know how to do the calculation. 8 take 3, 5. Okay, I'll just do it here. I'll show you how to use graphic calculator in a minute, but I'll just do it here. As 8, 7, 6, and then that's 5 factorial, 3 times 2 times 5 factorial. So 5 factorial cancelled out. 3, 2, 6. That's going to be 56 ways. Oh, good. Okay. That's pretty easy. There's no restrictions. And then B, the team must include the captain. Okay. So if you think about it, there are 8 in the squad. The captain is already a concrete person. Okay, so for example, if you guys think about it, for example, if you have a well, I know nothing about sports, but say if we have a sports team, and then say Ben will be the captain. So Ben's Ben, so he's gonna be the captain. So we know that Ben will be in the team. Okay, so there's only one Ben, so you have to include him in the team, and then pick another 2 from the rest 7 people. Does that make sense? Okay. So you already know Ben is the team. So therefore, you only have 7 people left. You already had 1 in the 3. So you pick 2. Does that make sense? Because as I said, the person who is the captain is already known. Okay, so that's C72, that's going to be 7 factorial, 5 factorial, 2 factorial. So once you do like 100 of these are quite easy to solve without a calculator. Okay, 7 times 6, and then 5 factorial cancelled out. And then times the 2. Okay, so that's going to be 7 times 3, 21. Oh, good. Okay. Okay, let's have a look at example 8.